Welcome to The Explainer. Today, we are going on a deep dive investigation. We're hunting for one of the most sneaky and damaging performance issues in cross-platform development, especially if you're using a framework like FireMonkey or FMX. We're talking about that slow, creeping death of an application's user interface. And we're going to expose the hidden culprit that is probably making your apps feel sluggish and unresponsive right now.
So for this analysis, we're going to follow a pretty clear path. We'll start by defining the symptom, what your users are actually feeling. Then we'll rule out the usual suspects before we identify the real architectural criminal behind it all. And finally, we're going to arm you with the modern tools and really a new philosophy to make sure your apps are fluid, responsive, and feel totally professional. All right, first things first, we need to define the problem. It's a feeling we have all had, right? Using an app that just feels off. It stutters, it hesitates. It's missing that smooth, liquidy feeling you get from a high-quality native application. But, this isn't just a feeling, it's a very real, measurable phenomenon. We often look for these really complex external reasons for performance problems. Is it a slow network call, a complicated database query? We spend hours profiling all these background tasks, but what if the root cause isn't in what the app does, but in how it's actually built? What if the performance bottleneck is hiding in plain sight, in the very structure of our user interface? So, the first term we really need to get our heads around is jank. And no, it's not just slang. It's the technical term for those stutters that make an app feel unresponsive and, frankly, kind of cheap. See, to get that smooth 60 frames per second, your app has this super strict budget. Just 16.67 milliseconds to do absolutely everything. Calculate layouts, draw components, run animations, and slap a new frame onto the screen. If you miss that budget, even by a tiny fraction of a millisecond, the system just drops the frame, and what the user sees is a stutter. And on modern high refresh rate screens, that budget gets even smaller. It's a tough deadline to meet.
And when things get really, really bad, the problem gets a whole new name. Android Vitals, which is the operating system's own health monitor, it flags what it calls a frozen frame. This is any single frame that takes over 700 milliseconds to render. I mean, that is an eternity in processing time. And this is what directly leads to that dreaded application not responding dialog. You know the one. It's a crystal clear signal to the user that your app is just completely failed. Okay, so every good investigation starts by looking at the most common culprits. Before we can zero in on our main target, we have to rule out all the other known sources of performance problems. And don't get me wrong, these are serious issues and you should absolutely fix them. But a lot of the time, they're just accomplices, masking a much more fundamental architectural flaw. So let's just run down the lineup of usual suspects. First, you've got blocking the UI thread with things like network calls. That's a classic mistake. Next up, data binding overload, where you update a huge data set and it forces the entire screen to redraw. We also see cold start lag, where a complex control stutters the very first time it animates because it's loading on the fly. And of course, overusing GPU-heavy effects or stuffing slow controls into fast-scrolling lists. Yeah, that'll grind your UI to a halt. All of these are bad, for sure. But even when you fix them all, a deeper problem can still be lurking. And now it's time to reveal the true culprit. This isn't just some simple bug. It's a design pattern. It's a way of building UIs that seems logical at first, but it is so bad for performance that people have called it a capital sin of mobile development. We're talking about the abuse of nested layouts. So here's the crucial point, and this quote really nails it. Deeply nesting layouts, putting a layout inside another layout, it creates what's described here as a matryoshka doll structure of components. It's a perfect analogy. Each layer adds another shell, and while it might look perfectly fine visually, under the hood, you are building a performance nightmare. Just look at this comparison. It says it all. The nested hierarchy on the left. To position a single button, a developer might stack 4 layouts. Now, when anything changes, the framework has to trigger this cascade of recalculations. The parent calculates its position, then tells its child to calculate, which tells its child, and on it goes. This creates a computational complexity that just explodes with each new level. But now look at the flat hierarchy on the right. It gets the same visual result, but in a single calculation pass. There's no cascade, just one clean, efficient operation. And this is not a new problem, not at all. As far back as 2013, developers were reporting these show-stopping performance issues on Stack Overflow when they were using a lot of controls. And the official response from the framework's own R&D team back then was basically, don't use a lot of controls. Now, that's not a real solution, is it? That was an admission that the framework's layout engine could get overwhelmed, and it forced developers to compromise on their UI complexity. And the performance penalty here is not theoretical. I mean, consider this real-world case. An enterprise app that was dynamically creating over 2,000 individual controls. On a powerful Windows PC, the screen took 3 seconds to load. Okay, maybe acceptable. But on a mid-range Android device, the same code took a staggering 17 seconds. That is not just slow, it's completely unusable. A user will assume the app has crashed and kill it long before it ever finishes loading. Okay, so we've diagnosed the disease. Now it's time to prescribe the cure. The solution is not to build simpler apps, it's to build complex apps in a smarter, much more performant way. The solution is to shift our whole philosophy from nesting to a much better approach: flattening. The core idea here is really simple, but it is so powerful. Flatten your UI structure. The goal is to design your interfaces with the absolute minimum number of nested containers possible. We're aiming for a structure that is only 1 or 2 levels deep, at the absolute most. This practice, hierarchy flattening, directly attacks the root cause of the performance problem by completely eliminating that devastating cascade of layout recalculations. So how do you do it? How do you create a complex UI without nesting everything? Well, the modern solution is this incredibly powerful tool called T-constraint layout. Instead of putting a button inside a layout to align it, you just place the button as a sibling to your other controls, and you create a constraint, a rule. You can literally say, this button's left edge should be attached to that label's right edge. This lets you define all these complex relative relationships between your controls all within a single flat container. You get the same visual result as a deeply nested structure, but with drastically better performance. It's a game changer. Curing the disease of nested layouts, that's the critical surgery, but ensuring long-term health, that requires adopting a full arsenal of modern performance tools. The FMX framework has evolved a lot, and leveraging these new technologies is absolutely essential for building truly high-performance applications. This chart shows the hard data. This is the evidence. It compares frames per second on a bunch of devices using the default FMX engine versus the modern Skia engine. And look, on a Motorola Android device, the FPS jumps from 25 to 38. On a high-end Windows machine, it goes from 83 to 91. Just by switching to Skia, which is the same high-performance graphics library used by Google Chrome and Android, you get an immediate, measurable, and significant performance gain across every single platform. Next up is a fundamental change to the very heartbeat of FMX animations, the display link service. See, the old system used timers to guess when to update an animation, which could easily fall out of sync with the screen's refresh cycle, and that causes stutter. The new Display Link service is a frame-accurate system that hooks directly into the platform's native VSync events. What that means is that every animation is perfectly synchronized with the display's hardware refresh rate. The result? Perfectly smooth motion. And of course, to keep that UI fluid, any operation that might take more than a few milliseconds must be moved off the main UI thread. This is not negotiable on mobile. And the modern way to do this follows 3 clear steps. First, create a T-task for your background work. Second, run the blocking operation inside that task. And third, once it's complete, use tthread.queue to safely pass the results back to the main thread so you can update your UI. That process is the blueprint for a responsive application. And there we have it. We've completed our investigation. We've identified the symptoms, we've ruled out the accomplices, unmasked the primary culprit, and we've reviewed the modern tools for a complete cure. The path to building high-performance, fluid mobile applications is now totally clear. You know, the crucial takeaway from our entire investigation is this. Great performance isn't something you find or fix at the end of a project. It is not a final optimization step you do before you ship. It is architected. It's a direct consequence of the design choices you make from the very first component you place on a form. That choice between a nested layout and a constraint-based layout, that is an architectural decision with massive performance implications. So, let's lock in the key takeaways. First, remember that jank isn't just a feeling. It's a measurable failure that users will not tolerate. Second, the primary cause is almost always an architectural flaw. Deeply nested layouts creating those cascading recalculations. The cure is to flatten your hierarchies with tools like T-constraint layout. And finally, you have to embrace the entire modern arsenal: Skia, display link, and proper threading. Your mandate, starting today, is to audit your UIs, hunt for those Matryoshka dolls, and refactor them for a truly fluid user experience.
Ultimately, this isn't just a technical exercise in chasing milliseconds. It's about respecting the user's time, their attention, and their perception of quality. They don't know why your app feels slow. They only know that it does. Every stutter, every dropped frame erodes their trust. The tools and the knowledge are now in your hands. Thank you for joining this deep dive from The Explainer.